All right, hello. This is the classification and regression project for AI. I am Tim, and my partner is Gabe.
Hi,
Um,
how's it going?
yeah, so we're going to be going over our notebooks with Google Drive collab that we worked on for the classification and regression models. So to start off, I'm going to start talking about the classification process that I did using Collab Notebook. So the data set that I chose was this one right here, which basically just takes different wine samples. I chose the red wine one, um, and I found it perfect because if you look here, it just has different data values like acidity, citric acid, sugar, chlorides, density, pH. So just a bunch of data we could work with. And the CSV is pretty extensive. So there's a lot of data to work with. So that's the one that I chose for the classification. So let me just start by walking through. So as you can see here, pretty much the same as the machine learning tutorial. We mount the Google Drive. It gives me, do you want to give permissions to load the Google Drive? I say yes. It loads it. I load the CSV, which is in my Google Drive, so wine quality red. And then this is just a few of the first five rows from the data set. So as you can see, we have split it up into the proper columns and rows. And then down here is more of the meat of the code. So we're using sklearn libraries for the scaling, and then the different models that I chose was the logistic regression model, the K neighbors, random forest, and SVC. So I'm just going to begin by starting to walk through the code. Oh, and then we also import the the plot library just to plot the different predictions for the different models. So as you can see here, we do the standard scaling, which basically just transforms the data, standardizes it based on all of the different data, like rows and columns which are within the data set. So the different features that we're going to be testing with. And then we define the models here. And then we set the logistic regression to 1,000 is the max iteration. And then for the K neighbors, we want the number of neighbors to be five. And then the random forest estimator set to 100. And then SVC, we just instantiate just SVC by itself. And then we create results right here. And then that results is what we're going to be appending to that results uh, the different reports that we receive back from the different models. So we have a for loop right here. So for the model within the model items, we basically just train the data with these different models, and we use model.predict to predict with each of the models. And then we print the name and then the classification report with a new line. And this is basically just all the data that we've gathered from running the different models. And then we create CM, which is the new confusion matrix, which we're going to be using with the Y test and then the Y prediction. And then the heat map is kind of like the graph that we decided to use for this one. So it's basically a heat map just showing the different predictions, which looks really nice. And then we just some CSS like the title, label, and then this is the plot showing the plot. And then here's us saving just the JSON for the classification results, which were created. So as you can see right here, we have the logistic classification report. So as you can see, for there's different position values and then different F1 scores here. So as you can see, it struggled more than the 4, 7, but it did pretty well with the 5 and the 6. And then down here is the confusion matrix, which was produced from the logistic regression model. So as you can see here, we got 98 and then 46 and 76 right here. And then kind of like, this is how it just shows that the predicted versus true is very high over here. And then down here we have the K nearest neighbors classification report. So it's a little bit similar to the linear regression, but just slightly different. in the numbers that it spit out. So the F1 scores here, you can see that they're higher for 5 and 6. 7 is actually higher than the linear regression model, but still overall a little bit similar, which is expected. But this is how the model decided to show the different predictions based on what's the true amount versus the predicted. And then down here we have the random forest classification report. So it's a little bit similar, but I think the numbers are a little bit higher. So as you can see here, they do pretty well with 5, 6, and 7 with the F1 score. And then the precision numbers and the recall are both similar to the previous two models. And then finally, we have the support vector machine, which is which is the last model that I decided to run through the data with. So we have 5 and 6 once again highest, and then pretty similar to the other models. And then this is the graph for it. And then overall, I just created like a little summary at the end. So this is just listing the different models that we used, and then we're listing the different accuracies that each model produced. So overall, the random forest one overall is the best model. It had a high F1 score, and then the accuracy was the highest. Strong precision for class 5 and 6, which most of them showed, high precision for 5 and 6. But this one was just overall the best one amongst the four models. And then down here is my data frame to CSV command, which is used to output the final CSV, which I will attach to the submission when we submit this product. And this is the process CSV that it spit out. But yeah, this was my report and my code for the classification models. Now, Gabe's going to take it over, and we're going to start talking about the regression models.
Perfect. Thank you, Tim.
Mhm.
Yeah, so for the regression model, basically, we did the same thing, or not the same thing, but similar thing to kind of like set it up. So we used the archive, the data set that you can see at the top there. So basically, it's a data set on student performance, and it basically measures some things like student achievement, gives demographics, grades, school features, and
Mhm.
so we thought this would be kind of a good thing to use for our classification regression model, because you can see right there, associated task, classification, and regression. So yeah, I think we'll hop into it.
Mhm.
You can see we did something similar as we did previously, where we import the actual file as a data frame and then put that in pandas, and then we make sure that everything is all there by printing out the head. And so you can see we have our student information, we have ages, we have addresses that are gotten rid of, family size, stuff like that. And then so basically in here is where our actual, where the meat of our model actually is, where we have our standard scalars, where we got where we're calling our model in here. So pretty much what we're going to start by doing is we're going to encode our columns, and basically the reason why we're doing that is to make it so they're actual readable columns. After we do that, we're going to select the features that we want dropped, and then we're going to scale the features in order to fit them into our model successfully. And after we do that, we're going to split it into our training data, our testing data, and then we're going to do that in our X-train, our X-test, our Y-train, our Y-test. And then we're going to be training our models on the training data that we pulled. We used the linear regression and random forest here. So pretty much we're putting them inside of our models array, data frame rather. And then we are going to have it train on our X train and our Y train. And then after it's trained on those, we're going to have it predict on X test in order to get our actual values. And then so we're going to find the error with the mean squared error by testing our Y test versus our Y predict. And then we're going to be printing out our R squared score in order to determine our accuracy. We're also plotting it too, but you'll be able to see that right here. So in our linear regression model, we find the R squared score. It's not bad. It's actually better than the linear regression for our other model with 0.75. So it's fairly accurate. Obviously, we'd want it to be a little bit more, but that's probably more so a limitation of the data set as opposed to anything else. Just we don't have enough data in order to correctly train. But overall, linear regression wasn't horrible. Mean squared error at 5.03 also wasn't terrible. It's what's it called? It's within a I believe it's 2 standard deviations. You can correct me if I'm wrong there, Tim. But I believe it's within 2 standard deviations, so it's not horrible. Not the best, but it's limited data set. Some things that we would want in real time to get work with. And then so here's our random forest model. You can see a little bit more accurate with an R squared score of 0.83. So pretty much random forest for this data set, kind of the way to go. I also believe it was the way to go for the red wine data set. So random forest for data sets, just data sets that we've been working with here, tends to be the way to go. Mean squared error of 3.53 is much better than 5. So yeah, overall, the random forest kind of ended up being a good way to go here. But and then so you can see here, we're going to save the final CSV similar to the way that we did previously. Yeah, so that's all good there. And then there's more summary of what everything means here. But yeah, overall solid performance from both models. Oh, random forest probably the way to go. And especially since linear regression isn't like we can't do too much with the linear regression. We can't do too much to improve it. But with the random forest, we can do a little bit more. We can add this what's it called, certain features, and make it a little bit more accurate. But yeah, overall, random forest, pretty good model.
Yeah. And that's going to be our video for Project 4 for the R regression and classification models. I hope you had a good Easter weekend. Thank you, Dr. Mosley.
Have a good one.